Hello, scholars. We are now on unit 4, which is for triangle unit. So what we're going to kind of do here in skill 4.1 is just kind of identify a lot of theorems that are useful for solving things in triangles. And we're just going to kind of focus on some of the angle problems in triangles. Before we do that, though, I want to make sure that we are familiar with the terminology here. So we have scaling, isosceles, and equilaterals. That's classifications using sides. Note that the short lines on the sides show that these sides are congruent in length. So make sure that you are copying these tables down in your notes. You may want to pause the video. And then we also classify our angles, our triangles using angles as well. So that's looking at what your largest angle is in the triangle. So if my largest angle is a right angle, we have a right triangle. Note, and I made a little typo here, but equilaterals are equiangular as well. And they are acute. All right, so let's actually take a look at this one here. Actually, Delta Math does give you kind of some answer choices. They're going to have you look at whether the sides are different or the same. And we have, for this one, all the sides and angles measured the same. So that leads us to equilateral. That is example 1. So expect several like these where you just get some practice classifying the triangle. All right. What we have here now is the triangle sum theorem and the exterior angle theorem. So I'm just going to kind of start with like a picture here. Maybe A, B, and C. So I could say here that measure of angle A plus measure of angle B plus measure of angle C equals to 180. So this just means the angles in a triangle add to 180. So that is a triangle sum theorem. The exterior angle is a little bit more complicated. Not much, though, in terms of the map, but in visualizing, I would say. We'll call this A, B, C, D. And what this is saying here is that the red angle is equal to the sum of the two blue angles. So these are called remote interior angles. And the red angle is called the exterior angle. So the exterior angle equals to the sum of the remote interior angles. So what that means in terms of a picture is that the measure of angle BCD equals to the measure of angle A plus measure of angle B. And that is the exterior angle theorem. So please stop the video here and take a picture of these two theorems that will help you become good solvers of these triangles. All right, the easy problems have pictures on them. So this is a triangle sum theorem. So I have 100 plus 5x minus 8 plus 48 equals to 180. So this is going to be 148 plus 5x minus 8 equals to 180. So that's 140 plus 5x. Subtract 140 on both sides. So I get 5x equals 40. Divide by 5. And I get that x is equal to 8. And I could just substitute that in. So I got 5 times 8 minus 8. So that's 32. So 100 plus 32 plus 48 equals to 180. So we are good. That is a basic triangle sum theorem problem. All right, let's go to a exterior angle problem. Now, what you could do on this problem is, since this is a number, you could actually like use the linear pair and figure out what this is equal to, and then do the triangle sum. But it's easier to add the remote exterior angles together. Remote interior. And set it equal to the exterior. So I'm going to do 134 equals to 114 plus x. So I'm going to subtract that, 114, and get x by itself. So I get x equals to 20 degrees. All right, how could we get a little harder on these problems? Well, I could actually give you a situation where we don't have a picture. So the ones that are a little bit easier without a picture are just the triangle sum. So we have a triangle called JKL. And it gives us that we have 8x plus 6, 2x plus 2, and 4x plus 4. And this just says draw a triangle. So then I'm just going to add those up. So I have measure of angle J plus measure of angle K plus measure of angle L equals to 180. And I'm going to substitute in what I have. So I have 8x plus 6 plus 2x plus 2 plus 4x plus 4 equals to 180. Combine like terms. So I'm at 14x. And then 6 plus 2 is 8 plus 12. 4 is 12. So I have 14x is equal to 168. So I'm going to divide that. And I get that x is equal to 12. But it's asking for find the measure of angle L. So I'm just going to put in the 12 in So that's going to be 48 plus 4, which is 52. And that's our final answer. All right, one more example. So this is the language that is a exterior angle problem. UW is extended through. So that's a signature for exterior angle problem. So I have UVW. And it says that UW is extended through point W to a point called X. And it says that VWX is 7x minus 14. It says that WUV is 2x plus 11. And then UVW is 3x minus 7. So remember, exterior equals to remote interior sum. So I'm going to have 7x minus 14 equals to 2x plus 11 plus 3x minus 7. And I'm going to combine like terms. So it's going to be 5x plus 4. And we move the 5x to the other side. So I have 2x minus 14 equals to 4. Add 14 on both sides. So I got 2x equals to 18. And then x is equal to 9. And that is the exterior angle theorem problem. So that pretty much covers all the types of problems you're going to see today related to the interior and exterior angles of all types of triangles.